All right, today we are focusing on lesson 1.1 in our book. So the whole chapter is about number operations. Lesson 1.1 specifically whole number operations. So it's kind of review. We've just spent the last day and a half reviewing multiplication and division of multi-digit numbers because you're going to see some of that in this lesson. So we're starting with example 1 where it talks about adding and subtracting whole numbers. Okay. You guys have been doing this for a while. You guys are probably pros at this. Sometimes you're going to have to borrow and regroup, carry, whatever may happen. You guys are pretty good at it. So let's look at the first example. It says the bar graph shows the attendance at a 3-day art festival. Okay, interpreting data from a graph and then using that information to solve a problem. Letter A says, what is the total attendance for the art festival? You guys kind of did something like this in the investigate, if you remember. Those 4 questions, you had to use the bar graph to answer questions for. This is kind of going along with that. Okay, so what you would do is you would add up the sum of the daily attendances. It's showing you that. It's already done for you right here. It's taking all of these totals, adding them up to get 9,591. So the total attendance is that number. It says, what is the increase in attendance from day 1 to day 2? So I'm looking at the increase from here to here. To find the increase, I want to subtract and find the difference. So they show you that process right here. They show you the borrowing. They show you the regrouping. They show you how they get 575 people. Are there any questions on that example? Yes.
Never mind.
Okay. Then they give you an example of multiplying whole numbers. So it says a school lunch contains 12 chicken nuggets, 95 students buy the lunch. What's the total number of chicken nuggets served? In order to figure out the total number of chicken nuggets, I'm going to do the number of students, which is 95 times 12 chicken nuggets, and it's showing you that math. What did they not write right here? They didn't put 0, the hero placeholder. However, what did they do? They left a gap, right? They left a space. So everything is still lined up correctly. I like to add in 0, the hero, so that I make sure everything stays in line. Okay, so if you don't want to do 0, the hero, maybe put an X there. But if you leave a gap, you're risking accidentally scooting your numbers over, and then you end up with the wrong answer. Okay, so then you just multiply. We've been practicing that. Your answer should be 1,140 chicken nuggets served. All right, now in your journal, you have a page where you have examples from the in-class practice below. It says, find the value of the expression, use estimation to check your answer. So what we're going to do right now is we're going to look at this page in our journal, and we're going to answer 1, 2, and 3 from the bottom of page 4 in our textbook. It says, find the value of the expression. When I find the value of the expression, that means answer. Expression is kind of like an equation, but it's different because it's missing the equal sign and the answer. An equation has an expression on one side a lot of times, and then you have an equal sign and then the answer. An expression is just the problem itself. So we're going to start by solving number 1. I want to rewrite it so that my numbers are lined up. So I'm going to rewrite that down here. I'm just going to put 682 underneath the number already there. I'll add it all together. And my value of this expression should be what?
2,427.
Yep.
427.
2,427. Now, if I am using estimation to check my answer, what do you think that means? What might that look like?
You estimate it.
How? What does that look like?
Bringing. You can either say the 27 is not more than 50, so bring it to 400, or do 430.
Oh, in my answer.
Yeah.
Okay. What if I wanted to look at my add-ins, this number and this number, and I wanted to estimate a sum?
You could put 100 and 1,700 and
You could.
And 600, or you could do 700.
You could do it that way. I could also round both numbers to the nearest hundreds place. So I could say 1700 plus 700. Or I could do 1745. I could round that up to 2000 and say, okay, well, 2000 plus, if I rounded 682 up to 1000, 2000 plus 1000 would be 3000. Okay, is this answer reasonable if I was rounding both of these numbers up to and got an answer of 3000? Yeah, it's reasonable. Okay, just checking for reasonableness. Question?
2,430.
You, I think, multiplied right here. You did 2 times 5 instead of adding. Okay, number 2. 912 minus 799. So I'm going to subtract 799. This is going to require some borrowing and regrouping. So when I borrow, that leaves me with 0 here. This becomes 12. 12 minus 9 is 3. Again, more borrowing and regrouping. That 0 now becomes 10, and 10 minus 9 is 1. 8 minus 7 is 1. My answer should be 113. Great job. Now if I estimated and I rounded 912 down to 900 minus about 800 is about 100, is my answer reasonable? It is.
Yes.
Okay, last one. I have 188 times 42. Do I want to put 188 underneath the 42? No, you always want to put your number that has the most digits on top. So I'm going to actually rewrite this. I'm going to put 188 and then times 42 off to the side.
That's what I did.
Now, whenever I did the notes in our journal, I color coded. So I'm going to do the same thing because I like to show my partial products all the same color. So 2 times 8 is 16. That would be 17, and that would be 3. Then I'm going to move on to my second partial product. So I'm going to put my 0 the hero down here and mark out everything I just used. Now I'm moving to the 4 in the tens place. I'm going to distribute that 4 to every single one of my top numbers, starting with 4 times 8 in the ones place. So 4 times 8 is 32. Carry the 3. 32 again, plus 3, 35. And then 4 times 1 is 4, plus 3 is 7. Now I can total that up to get my final product.
7,896.
Yes, 7,896. Now how can I use estimation to help me on this one? If I rounded 42, what would I want to maybe round that to? 40, okay. 188, to make it really easy in my head math. 200. 200 times 40 is about 8,000. Okay, is 7,896 pretty close to that? Yes, so my answer is reasonable. Okay, that's all we're going to have time for today. We will finish this tomorrow. Okay, so today we are continuing our lesson 1.1. It's over whole number operations. Yesterday we got through the first section, and then we got down and did the first 3 problems of our in-class practice in that little green section at the bottom of page 4. Okay, we got done with all of that. We used estimation to check to make sure our answers were reasonable. We are going to continue on in this lesson today. So now we're looking at example 3. It says solving a problem using division. So if we have a problem like the one on the board or in your book on page 5, it says you make 12 equal payments for a go-kart. You pay a total of $1,380. How much is each payment? So we are given a total. It's asking us how much is each payment. When I'm given a total and you see the word each, that should signal to us that we are dividing. I'm given how much I have total. That's what goes in the division box. I'm dividing it by 12. So it's showing you all the division steps right down here. It's explaining each of the division steps for you. And it tells us that the quotient is going to be 115. How do I check to make sure that I did it right? You can take the quotient, multiply it by the divisor, and you end back up at the dividend, which is 1380. Okay, so that's your completed example. We're going to do a few practice problems together. So in your journal, you'll see these 4 problems. They are all written a little different. We have two that are given to us like in a number sentence with the traditional division sign. We have one, which is number 5, written as a fraction. We know that fractions are just division problems. And then we have one that's all written out in words, so it's important that you know the word quotient. So when you see quotient, you know you are using division. Okay, so let's look at that page in our journal and go ahead and solve these next few problems. So I'm going to rewrite number 4 so that I have 234 divided by 9. I know 9 cannot go into 2. I always start left to right. So I'm going to put a placeholder just so I keep everything nice and neat, lined up. 9 goes into 23. How many times? 2 times, which is 18. Now I subtract. And then I bring down. And 9 goes into 54?
6 times.
6 times. And then I subtract, and I have nothing left over. So number 4 should be 26. Oh, I borrowed, sorry. I just didn't show that step to make this 13. Number 5 is 986 divided by 58. So I've got to ask myself, how many 58s can go into 9? 0. How many 58s go into 98? 1. And I subtract 58 times 1, which is 58. I have 40 left over, and then I bring down. How many 58s can go into 406? If we're not sure, estimate. 58's close to 60. 406 is close to 400. How many 60s could go into 400?
3. No.
How many 60s could go into 400?
8.
60 times 8 would be 480.
4.
6. So if I did 60 times 6, that'd be 360. So let's try 58 times 6 and see what it gives us. This would be 348. Could another 58 work? Let's add it and see. It's exactly 406. So that means 58 goes into 406 how many times? 7 times. So my answer for this one is 17. Okay, I'm going to let you try number 6 and 7, and then we're going to check it together to see how... we're not to number 8 yet. We're only on number 6. I know it's set up kind of funky. Sorry. Okay. So you should have worked out 6 and 7, or you were trying to work out 6 and 7. Number 6, 105 goes into 840 exactly 8 times, so your answer is 8. On number 7, your key word here is quotient. I said earlier that when you see the word quotient, you know you should be dividing. You have to know those vocab words for division. Quotient is the answer to a division problem. So I'm going to divide 9,920 by 320, and my answer is 31. How are we feeling so far?
I'm good.
Okay, let's keep going because we're almost done with our examples. Okay, this is our last one. It says connecting to real life, so it's giving us a real life problem. And it says a swing at an amusement park can seat 64 people. A total of 10,250 people rode the swing today. All the rides were full except for the last one. How many rides were given? How many people were on the last ride? You want to find the number of groups of 64 in 10,250. So to solve this problem, we're going to find the quotient of 10,250 and 24 by using division. So it's set up there for you. It shows you exactly how to work out that problem. My answer is 160. Remember I said we don't use remainders anymore. We write our answers as either mixed numbers or decimals. So what that quotient means is that there were 160 full rides given, but there were 10 people left over that rode that last one. So if I was answering the question, 161 rides were given, 10 people rode the last ride. Okay, and then to check it, you go back and you add, or you don't add, sorry, you multiply your quotient of 160 times the divisor. You end up with the dividend by adding those 10 extra people at the end. Okay. All right, so let's look at number 8. This is in your journal. It says, whoa, a boat can seat 582 passengers. A total of 13,105 people rode the boat to the base of a waterfall today. All of the rides were full except for the first one. How many rides were given? How many people were on the first ride? This is just like the one that we looked at, except for it's a boat, not a swing ride, and it's the first ride, not the last ride, okay? So we're going to be solving it in a very similar way. So I want to take my total number of people, which is 13,105, and I want to divide it by the number of passengers a boat can hold at one time. So I'm going to be dividing by 582. Okay. How many groups? Now, we can estimate to make it easier. So I could bump 582 up to 600, so it's an easy number to work with. And then just round, because I know it can't go into 1, it can't go into 13, and it can't go into 131. So I could round that to 1,300. So how many groups of 600 can go into 1,300? 2. Okay, so 582, because I have to know exactly what 582 times 2 would be 1164. Can another group of 582 go in, or would that be too much? That would be too much. So I'm going to put a 2 up here, and I'm going to subtract 1164. And I have 146 left. But what do I need to do? Bring down the 5. Okay. I know that 582 times 2 is 1164. I'm trying to get a number close to 1465. If I added another 582 to 1164, it'd be too much again. So again, it can only go in 2 times. And again, I'm going to subtract 1164. So what does you can write all over your page. You just keep on going. Yeah, you can write on the notebook. Yes, it's on paper, so you can go underneath the part you cut out. That's fine. Okay, so what does my answer mean when I look at this? There were 301 people left. How many total rides had to be given, though? I can't just do 22 because I had 301 people like over here off to the side. But remember, that first boat ride wasn't full. So how many total rides were given? 23 rides were given. So 23 rides were given. And the second question says, how many people were on the first ride? 301 people were on the first ride. And I'm just using numbers. First ride. Okay. How do y'all feel?
Good.
Feel okay?